All right, we are now at lesson 1-3, and you can see our title there, Locating Points and Midpoints. We are interested today in this lesson in showing you some formulas to help you find the midpoint of a segment, whether that midpoint is between two endpoints on a number line, or it could be the midpoint between 2 points on the coordinate plane. We have a formula that's similar but different for those two situations. And then we'll have some other cases where we're just locating a point on a segment given a fractional distance from one endpoint. And so we'll look at that in the latter part of this lesson. So let's just jump right in. And first of all, look at some formulas. Pretty easy formula if we're trying to find the midpoint here labeled as M in between two end points on a number line, here given as A and B. The values are represented by variables, of course. So all we do, if we're wanting to find the true midpoint, we just take these two values for point A and point B, we add them together, and then we just simply divide by 2. It's like finding the average of these two endpoint values. So we'll do an example of this using a real-life situation. The temperature on a thermostat dropped from a reading of 25 degrees to -8 degrees. What is the midpoint of these temperatures? So we just take the 25-degree measurement, we add to it the -8. Those are considered the end points. And then you divide by 2. And the 25 plus -8, of course, is 17 divided by 2. And in decimal form, that would be 8.5 degrees. Or you could have used the degree symbol there. So 8.5 is the midpoint between those two end points. All right, so let's take a look at some other examples. Here we have the number line, and we're asked to find this distance. It's called segment BD, but that's just another way of saying if we know the distance between those 2 points, that's another way of saying that is the segment called BD. So we just take those two end points. 0 is the value of B, and 18 is the value of D. And we divide that by 2. 18 divided by 2, of course, is 9. And the directions say to use the number line to find the coordinate of the midpoint of each segment. So that coordinate in this case would be 9. And you won't have a number line that you have to draw, but just so you can see, 9 would be right here because these are in increments of 3. And so 9, as you can see, does fit as the midpoint between those two end points. And then we'll do this again with segment AC. What is the point that is right in between? And so we just take the value of point A on the number line. We add to it the value of point C and divide by 2. And -6 would be in the numerator divided by 2. And so that would be -3, which would be located right here. So those are our two coordinates that we were supposed to find that represent the midpoint of those two segments. And when we get to the coordinate plane, it's a little different because remember on the coordinate plane, points are represented by X and Y coordinates. So the formula I've provided for you here to find the midpoint between points P and Q, given here on this example, we will take the two X coordinates for P and Q, just lift those up and add those together and divide by 2. And that will represent the X coordinate of the midpoint. And then we'll do the same thing with the two Y coordinates. So we'll pull out the two different Y coordinates, add them together, and then divide that sum by 2. And when we do that, we will have the midpoint of these 2 points on the coordinate plane. So we'll take a look at some of these examples. Here are 2 points we're told that are coordinates on the coordinate plane. These are end points. So what is the midpoint? So to find the midpoint, we take the 2 x coordinates, 5 and -4, add them together, divide by 2, and then we take the 2 y coordinates, 12 and 8, add those together and divide by 2. And then when we simplify, we will have the xy coordinates for the midpoint. So 5 plus -4 is 1/2. So the x coordinate of the midpoint is 1/2. The y coordinate is going to be 20 divided by 2, which is 10. And so that represents the coordinates of the midpoint of those 2 end points. All right, another example. What is the midpoint between C and D? So we take the 2 x coordinates, -8 plus 5 divided by 2. Take the 2 y coordinates, -2 plus 1 divided by 2. So to get the x coordinate, -8 plus 5 is -3/2, or you could have said -1.5. And then the y coordinate is going to be -2 plus 1, -1/2, or -1/2. All right, so you're going to get some practice with these midpoint formulas for the number line and for the coordinate plane. Now we have some other problems where we're asked to find missing coordinates. And so we're told on letter A that we do have a midpoint. Okay, so find the coordinates of J. All right, J is unknown, but we do know what K is, and K is the midpoint of this segment. Okay, so if you wanted to do a little sketch, the entire segment is called JL. Not necessary, but for some people, pictures help. And K is the midpoint. So this is on the coordinate plane, but I'll just use this as a little sample. All right, so K is the midpoint. I didn't want to draw a whole XY coordinate. And L has coordinates 3, -5. Okay, so what is J? What are the coordinates of J? Well, using our formula to find this, again, this is on the coordinate plane. We know that because we're given XY coordinates. So the formula to find the midpoint, again, I'll just write it up for you. We take the 2 x's, add them together, and divide by 2. And then we take the 2 y's from the 2 endpoints, add those together, and divide by 2. Well, for J, right now, we don't know what the coordinates are for J. That's what we're trying to find out. So we could set up this formula as the x coordinate of J added to the x coordinate of L, and divide that by 2. And we know that when we do that, we're going to get the x coordinate of -1 because they gave us the coordinates of the midpoint. And now we'll set up the same thing for the y coordinate of the midpoint. So the y coordinate of J added to the y coordinate of L divided by 2 should give us the y coordinate for K because it is the midpoint. All right, so using a little bit of algebra, this is an equation where we're trying to solve for x. And solving for x will mean getting rid of this denominator. So my first move will be to undo division by 2, and we undo division with multiplication. So I'm going to multiply both sides of this equation by 2, which will cause these 2's to cancel. And that gives me x plus 3 is equal to -2. And so x, after I subtract 3 from both sides, is going to be -5. All right, so that's going to be the x-coordinate for J. And now let's find out what the y-coordinate is. So same procedure, multiply by 2 on both sides. So we can undo division. Y plus -5 is equal to 4. And then when I add 5 to both sides, I get 9. So J must have the coordinate, it must be the coordinate -5, 9. Okay, let's do one more of those. Sort of like it. Find the coordinates of G if P is the midpoint. Okay, again, I know this is on the coordinate plane, but I just want to provide a little picture just so we can see what's going on here. EG is the entire segment, and P is the midpoint. And we're told the coordinates of the midpoint. We're also told the coordinates for E. And we're supposed to find the coordinates for G. All right, so pretty much the same type of deal we did before. P, the midpoint, is found by taking the two x-coordinates from the end points. And you could turn this around if you wanted. X minus 8 really doesn't matter. All right, so when I do the two x-coordinates added together divided by 2, I should get -5 because that's the x-coordinate of the midpoint. And then when I take the two y-coordinates, add those together and divide by 2, I should get 10. So just like we did before, we're going to multiply by 2 on both sides. And -8 plus x is -10. And when I add 8 to both sides, -10 plus 8 is -2. All right, multiply by 2. 6 plus y is 20. Subtract 6 from both sides, and I get y is 14. So G has the coordinates -2, 14. All right, so hopefully when you see those types of problems on your homework, you'll be ready, or maybe you'll need to come back and refer to your notes, but just want to prepare you for those. And then here's some other problems utilizing algebra to help us find the measure, in this case, of PQ. All right, if Q, we're told that Q is the midpoint of this entire segment. So P and R are the endpoints and Q is the midpoint. So since Q is the midpoint, we know that PQ is equal to QR. Okay, it creates two congruent segment measures. All right, so since they're the same, we can write an equation showing that they are equal. And then we can solve for y, and if we know the value of y, then it'll make it easy to find out the measurement of PQ. So we'll subtract 5y from both sides. Add 2 to both sides. And then divide by 4. So we're given, we know that the value of y is 4, and so now that'll help us answer the question, what is the measurement of PQ? So PQ is given as 9y minus 2. So 36 minus 2 is 34. So PQ, let's finalize this, is equal to 34. All right, let's try this one. Find the value of x. Okay, so we don't have a drawing for letter B, so let's just sketch one out. Not saying you have to. Some people can do okay without it. but if you have to, I know some people like to have a visual. Find the value of x if C is the midpoint of AB. All right, so AB are the endpoints. C is the midpoint. AC is 4x plus 5. And AB, the entire segment, is measured at 78. So this one's a little bit different. But what we do know is that if C is the midpoint, then AC is the same thing as CB. Okay, so if they're the same thing, then I can write an equation basically that says 4x plus 5 plus 4x plus 5 is equal to 78. And now I just combine like terms. 8x plus 10 is 78. Subtract 10 from both sides. 8x is 68. And then x is going to be 68 divided by 8. And we'll just go to our calculator and get a decimal answer. 68 divided by 8 is 8.5. And we were supposed to find the value of x, and we did that. And that is your answer for this problem, letter B. All right, let's move on to the last type of problems that we're going to do are, these are not midpoints that we're trying to find between two endpoints. We want to be able to find any point in between two endpoints that's what we call a fractional distance. So let me just kind of set up this first problem, letter A. We're supposed to find the point called x on this segment identified as AF. All right, so from A to F, you can see here on our number line. But this point on x, or called x, is only 1/6 of the distance. So it's not halfway, it's 1/6 of the way. So it's like if we started at A and we went 1/6 of the distance to F, where would we land? So the way we find that is we go ahead and find the distance from A to F. And of course, the distance between 2 points is another way of saying the absolute value. So -7 is the value of point A, and 5 is the value of point F. So we do the absolute value. The absolute value of -12 is equal to +12. And then, because we're told to find the point that is 1/6 of the distance, then we just do that calculation. What is 12 times 1/6? Well, that's 2. So 2 is the number of spaces or units that I move from A toward F in order to land on the proper point, which will be my answer. So in other words, I'm going to start at A, I'm going to go 2 units, and after I do, I will be on what they're calling X. X has a value of -5. All right, and so that's what you will do when you are locating a point that's a fractional distance on the number line. Now, what do we do for the same type of situation, a fractional distance from one point to another, but it's on the coordinate plane? Well, it's very similar. We find the distance between the x coordinates. All right, so here's I'll just do it like this, the distance between the x coordinates, -3 minus 2, absolute value of -5, which is +5. Okay, and then I'm going to multiply this +5, which is the distance, times the fractional distance that we're asked to find. So 5 times 1/5 is equal to 1. Okay, now we'll come back to that 1 in just a second. Let's just go ahead and do the same thing for the y coordinates. All right, so find the distance between the y's. -3 minus 3. That's the absolute value of -6, which is +6. And now multiply that absolute value, that distance, times the fractional distance that we're trying to find. 1/5 the distance from n to m. So if you do 6 times 1/5, that's 6/5. Okay, so now it's from n to m. So it's like you're starting at m and you're going to travel from n this many units after you multiply by the 1/5. You're going to travel that many units. So it's kind of like this. From the x coordinate of n is -3. I'm going to run out of room here. We'll do it like this. So for the x coordinate, it was at -3, and since we're going to the right on the x-axis, we're going to add 1. And so the x-coordinate, that is 1/5 of the distance from n to m, would be -2. And then to get the y-coordinate, not only are we going to the right on this line, but we're also going up. It's got a positive slope, in other words. So we take the y-coordinate, which is also happens to be -3. And again, we're going to add 6/5. That's way down there, so I apologize. So if you want doing fraction work, you could change -3 into -15/5. So let me just come up here where it's easier to see. So -15/5 plus 6/5 is -9/5. So I'm okay if you wanted to use your calculator and get a decimal for that. That's fine. But in fraction form, that point called P, we'll finalize our answer here. P is the point 1/5 the distance from n to m. It would be the point -2, -9/5, or the decimal equivalent of -9/5 would be okay. All right, and then finally, last type of problem, locating a point given a ratio. So both of these problems, A and B, are going to utilize this coordinate plane. All right, so let's take a look at what letter A is asking. So we're supposed to find this point that is called C, that is on AB, such that the ratio of AC to CB is 1 to 4. Okay, so in other words, C lies somewhere in here, and the ratio, it's going to be placed at a point, it is located at a point where AC, let's just pretend like C is right here. So AC is, in other words, the ratio 1 to 4 would mean this. All right, you can think of it this way. The distance for CB is 4 times greater than the distance AC. Okay, that's what this ratio of 1 to 4 means. In other words, if AC is measured at 2 units, then CB must be measured at 8 units. If AC is measured at 3 units, then CB has to be 12. That's a 1 to 4 ratio. If CB is 4 times longer than AC. Okay, so you got to kind of get that picture in your mind, and we're supposed to find out exactly where that point would be. What would the coordinates be for that point? All right, so let's use some algebra to help us out. If it's true, and it is, we're told that AC is, or CB is 4 times CB. We just did some examples, so I'll put this back. If AC is 2, then CB is 8. So another way of saying that is CB is 4 times AC, right? So we could do some algebra like this. CB is equal to 4 times AC. All right, so all together, if we did AC, AC plus CB, we would get the entire length AB. All right, all I'm doing is pretty much stating the obvious, that the segment AC, whatever it is, we don't really know the length of it, but whatever it is, added to the segment CB has to be the entire length. And using substitution, we just said that CB is the same thing as 4 times AC. So substitution says if these are the same, I can replace CB in this equation with 4AC. And now I can combine like terms. And I can solve for AC by multiplying by 1/5 on both sides of this equation. So we know that AC is going to be 1/5 of whatever AB is. Okay, well, let's find out what the distance of AB is. Sort of like what we just did. We find the absolute value of the x coordinates, we find the absolute value of the y coordinates, and then we'll multiply by 1/5, and that'll give us some guidance on where this AC, where this point C is going to be located. Okay, so first let's find out what the distance is. So let's take the x coordinates. So -4 minus 1. And I'm running out of space, but that's the absolute value of -5, which is 5. All right, so the distance between the two x coordinates for the entire segment AB is going to be 5. And then the distance between the y coordinates, absolute value of 6 minus 2, is 4. All right, so that distance is 4. Okay, so let's take these two distances now and multiply each one of them by 1/5. All right, so 5 times 1/5 equals 1. 4 times 1/5 equals 4/5. All right, so now going from A to B, locating where C is, this is how far we're going to move from A to get to C. All right, so as far as the x coordinate goes, if you notice, if you think about the x-axis, I'm moving to the right. Okay, I know I'm moving down, but that's what the y-axis does. As far as the x-axis is concerned, I'm moving to the right. So that means I'm going to add 1 to -4. And when I do that, I get the y coordinate for point C, which was be -3. Now this is a little tricky because to get from this point A to this point B, traveling on the y-axis, we're actually going down. And to go downward, that implies subtraction. Okay, so if you wanted to change this to decimal form, you could. 4/5 as a decimal is 0.8. So we would start at 6, which is point A, and we would subtract 0.8, and we would get 5.2. And that represents the answer here. That is point C's coordinates. It would actually be just rough sketch, -3, 1, 2, 3, 4, 5, and then just a little higher. So that would be the point that would be 1/5 of the distance. I'm sorry, going back to the original problem. This CB distance is 4 times greater, should be 4 times greater than this AC distance. All right, let's try one more of those. There's quite a bit going on in those problems. So this time we're going to find between these 2 points, we're going to find point D such that the ratio of AD to DB, DB in other words is going to be 3 times longer than AD. All right, so D is in here somewhere. And just to give you a little picture, this is D. DB should be 3 times longer than AD is what that's saying. Okay, so we could set it up like this. DB is equal to 3 times AD. And going back to our original equation, AD plus DB is equal to AB. Substitution, in place of DB, I'm going to put 3AD. Combine like terms, this is 4AD. Solving for AD, multiplying by 1/4 on both sides, that's going to be 1/4 AB. So we know that whatever the total distance of AB is, AD is only going to be 1/4 of that. All right, so now let's find out what that total distance is from A to B. All right, so the x coordinates, absolute value -4 minus 1, that's going to be 5. Y coordinates, 6 minus 2, that's going to be 4. And now we multiply by this fraction. So what we found here basically is the distance AB, and now we need to multiply by the fraction 1/4. So 5 times 1/4 is 5/4. 4 times 1/4 is 1. So that's how far we travel. We're going to go adding this to the x coordinate of A. We'll subtract this from the y coordinate of A, and that will give us point D. Okay, so when we add 1.25, so -4 plus 1.25, let's go down here and put our coordinates for D. -4 plus 1.25 is -2.75. And then the 6 is the y coordinate, and remember we're going down, so that means we're going to need to subtract the 1, so 6 minus 1 is 5. So that is our coordinates for D that will represent this ratio of 1 to 3, where DB essentially is 3 times longer than AD. All right, I hope that helps, and as usual, if you have any questions, you're welcome to come see me in academic support. Otherwise, I will see you next time.